All right, over the weekend I had practice and review of some middle school concepts on perimeter and area that's going to move us into our high school geometry lesson today. On the perimeter side, I just want to remind you by taking a highlighter or marker around each figure that perimeter is the distance around a figure. The inside of all of these are shaded, but I just want to remind you that perimeter stays focused on the linear sum of the side lengths all the way around each figure. And we even see some notation here that's been introduced in high school geometry, the congruent markings on the figure like number 9. If this side is 3 feet, this side is 3 feet. If this side is 2 feet, this side is 2 feet. For the perimeter of number 4, all I needed was a calculator here for this. This is a rectangle, I'm assuming, so I've got 90 feet on two sides and 65 feet on two sides. So all I'm going to do is add up two 65s. 2 times 65 plus 2 times 90. I get 310 feet. And again, I'm leaving it as linear feet because I'm only adding up the lengths around the figure, not having anything to do with the square surface inside. When I added up 12.1, 15.4, and 13.5, I got 41 inches for number 5. When I look at number 6, I'm seeing fractions. You could turn them into decimals, but at the same time, I think I could pretty easily convert to a fraction, every one of these fractions over 8, 1/4. If I multiply 1 over 4 times 2 in the top and bottom, I find out that that's 2/8. 1/2, I'd have to multiply by 4 in the top and the bottom, that's 4/8. Then I can go around and I'll simplify this in a minute, but I'm counting up eighths. I've got 2/8 plus 5/8 plus 4/8 plus 3/8. So that's leaving me with 14/8. And if I reduce this by dividing everything by 3, by 2 because they're even numbers, I'm going to get 7/4. And then if I go even further, 4 goes into 7 one time with 3 out of 4 left over. Now, if you had converted this into decimals, they were all nice terminating decimals, you would have finished with an answer of 1.75. Number 7, just adding all the way around. Let's see, 1, 2, 3, 4, 5. This is a regular pentagon. We'll be talking more about that in class even today. I did 2.3 times 5 to get this, 11.5 centimeters. Perimeter here, now I see these markings that we've experienced showing congruence on all these sides. So if I start going around, I've got 2 yards, 3, 4, 5, 6, 7 yards is the perimeter of this figure. And then number 9, let's see if I can just add these up, 5, it's going to be 10 feet. In number 10, you're wrapping a ribbon around a rectangular box that's 18 inches long and 12 inches wide. Well, if I'm going to go around the box, wrapping it around the box, that means that I've got to go 18 is going to happen twice. 12 inches is going to happen twice. So at a minimum, and this is without anything extra to tie it in a bow, which I would assume you'd do, you need at least 60 inches of ribbon. A county has the shape of a quadrilateral, 4-sided. The lengths of the 4 sides are, and they give them to us, all we have to do is add those together. 109 plus 94 plus 82 plus 109. 394 miles is the perimeter of this county. So that's our perimeter side. When we flip this over and we review area, makes sense to me that they've got these shaded in here because this exemplifies that we're figuring out space inside. Now, I had some questions in class on Friday with people working on this after their quiz, and all the formulas were at the top of the page. Some examples were at the top of the page. And I helped a few people identifying what the figures were. If you've got to make some changes on this document, go ahead. I'm going to assume that this is a rectangle, and the formula for a rectangle is to take the base times the height. So I'm going to go 50 feet times 30 feet, and that's going to leave me with 1,500, and I did multiply feet by feet, so I'm dealing with square feet. Whenever we're measuring area, we're dealing with square units. Number 5 is a triangle. The area of a triangle is 1/2 times its base times height. Now, the other way you can write this is 10.6 inches times 13.5 inches, and then divide that by 2. Just be careful that in your calculator you're pressing, oops, I had 3.5, I need 13. Just be careful that in your calculator you press enter. We get 143.1 divided by 2, then do our division by 2. 71.55 square inches for number 5. Now this is number 6 is a trapezoid, and it's actually sitting kind of, it's not sitting where it's conducive to matching up the formula. We've got trapezoid formula says you take half of the sum of the bases. We're going to call this one little b, we're going to call this one big B, and then the height. And I'm turning it over on its side to show you that the bases are meant to be those sides that are parallel in a trapezoid. Since I'm using multiplication, I'm not going to worry about doing anything with these fractions, just times and multiplying them together. So let's see here, the area is going to be half of, oh, I am going to have to do some changing of denominators here. The sum of the bases is a fourth plus a half, and then in the end I'm going to have to multiply that all by 3/8. So I've got a half times this sum times 3/8. Now I'm going to think about the half as 2/4. So then I'm looking at a half, let's see, 2/4 and 1/4 is going to give me 3/4. So I've got a half times 3/4 times 3/8. And in multiplying fractions together, all you do is go across the top. 1 times 3 times 3 is going to give me 9. And across the bottom, 2 times 4 is 8 times another 8 is going to give me 64. This is going to be 964 square feet. 9 divided by 64, if you have it as a decimal, is about 0.140, nope, it's exactly 0.14065. Number 7, what I did realize, and I had a few people pick up on this before they left school on Friday, you had to split these into triangles and then add them together. So find the area of what I've got shaded in brown, then find the area of what I've got shaded in green. 6 times 4 divided by 2. The brown one's going to be 12 centimeters squared. 6 times 4 is 24. When I divide that by 2, I get 12. 5 times 5 divided by 2. Again, 1/2 times base times height. I'm just looking at it as do my base times height and then divide by 2. I'm going to have 25 divided by 2. That's going to be 12.5 centimeters squared. And then to put the two together, the area of the entire figure is going to be 24.5 centimeters squared. I did that just by adding. Now this problem's a little unique because you've got to figure out what the dimensions of both of these rectangles are. I can see that this rectangle here is exactly 8 yards by 6 yards. That's going to be 48 square yards. And when I go over here, I've got to do some adding together. If this little piece is 2 yards and the rest of it was 6 yards, I've got 8 yards total for this length. So 8 yards times the 2 yards down here for that dimension is going to give me 16 square yards for that. 48 plus 16 is putting me at 64 square yards. When I go over to number 9, this is a parallelogram. The parallelogram has the same formula for area as our rectangle. It's going to be 2 feet times 3 1/4 feet. And I'm actually going to go on my calculator and do 2 times 3.25. 3 1/4 is 3.25. I'm getting 6.5 square feet. You could write that as 0.5 as well. Number 10, you're carpeting a rectangular room that is 3.5 yards by 4.5 yards. 3.5 times 4.5 is giving us 15.75 square yards of carpeting. Go on to learn that the carpeting is $15 a square yard. I'm multiplying my 15.75 square yards by the price 15. It's going to be $236.25. Let's see. Colorado is approximately a rectangle that's 280 miles by 380 miles. 280 times 380. Let me see what I'm getting here. Is the area of Colorado greater or less than 100 square miles? Explain. Well, 280 times 380 is equal to 106,400 square miles. So yes, it's bigger, and I've got my mathematical evidence to prove it. This is just the segue into our geometry lesson on area and perimeter, and we're going to learn more about naming polygons, among other things.